Alright, in this lesson we are going to talk about the order of operations and like terms. So these are the steps in the order of operations. This tells you which things to do first, second, third when you're trying to solve a problem. So the first thing you want to do is the parentheses, and actually this means any kind of enclosures, and we'll talk about all of these more in a minute. So the first thing you want to do are any parentheses or other enclosures that you have. Then you will work through any exponents. Then you do any multiplication and division you have. Then you do the neighbor sign rule. That was an earlier lesson that we talked about. Then you group same signs together. Then you apply the same sign rule. And finally the mixed sign rule. And a way to remember all of these steps is this little phrase right here. Please eat more dessert. Nate's Great Strawberry Mousse. And if you can remember that, please eat more dessert, Nate's Great Strawberry Mousse, you'll remember parentheses, exponents, multiplication and division, neighbor sign rule, group, same sign rule, mixed sign rule. So I'm going to say it again. The phrase is, please eat more dessert, Nate's Great Strawberry Mousse. So let's look over here at what happens if we don't follow the order of operations correctly. So for this one right here, this is an example of having to do parentheses before exponents. The right way to do it is we do whatever's in the enclosure first, so 2 plus 3 is 5, and then apply the exponent. So then we do 5 squared, or 5 times 5, which is 25. The wrong way to do that would be to do the exponent first. So we're going to say we'll do that. So we have 2 squared plus 3 squared, and that would end up being 4 plus 9, which is 15, and that is not the correct answer. So remember, parentheses before exponents. Over here, exponents before multiplication. You know, I'm just going to write the whole thing up here so we see it. So please eat more desserts, Nate's Great Strawberry Mousse. So we do exponents before multiplication. The right way to do this is to do the exponent first. So 3 squared is 9. So then 4 times 9 is 36. The wrong way to do it would be to do the multiplication first. 4 times 3 is 12, and then square 12, which is 144. That would not be right. Right, over here, multiplication before addition. So you can see that we do the multiplication first, and then all this stuff over here is our subtraction and addition. So we have to do the multiplication first. So the right way to do this problem would be to do your multiplication first. So we have negative 12 and positive 16. And then we would apply our mixed sign rule. We have more positives. We have 4 more positives. The wrong way to do it would be to do our addition first. So like doing this first. So that would be like negative 3 times 6 times 8. And that would be negative 18 times 8, which would be negative 80, and negative 64, 80 and 64, so it would be negative 144, and that would not be correct. Alright, so this is practice. You're just going to practice following the order of operations here. So remember, we're doing please eat more desserts, Nate's Great Strawberry Mousse. Alright, so pause it and try these problems, and then hit play when you're ready to check your answers. Alright, so parentheses first. So here we would do 8, and 8 divided by 2 is 4. So we're doing 8 times 4, which is 32. Here we do the parentheses, or whatever's in the enclosure first. 20 take away 15 is 5, and then we have to square that. We get 25. Alright, here what do we do first? Do we have any parentheses? No. Do we have any exponents? Yes. So we're going to start with the exponents. 4 squared is 16, so we have 16 take away 25. And now we have a mixed sign problem. So we have more negatives. And how many more negatives? 9. So the answer is negative 9. For D, we don't have any parentheses. We don't have any exponents. Multiplication, division. We have a division thing right there. So negative 15 divided by 3 is negative 5. So we have negative 5 take away 11. Now we have a same sign problem. Negative 5 and negative 11 is negative 16. Alright, for E, no parentheses, no exponents, no multiplication, no division, no neighbor sign rule, but now we can group. So we have positive 4, positive 7, negative 3, negative 6. Now we're going to do the same sign rule. 7 and 4 is 11, and negative 6 and negative 3 is negative 9. Now we'll do the mixed sign rule. We have more positives. How many more positives? 2. Alright, so let's talk about what we mean by enclosures. So when we are talking about the order of operations, we're calling them parentheses, the first step that we are using, and it really means any kind of enclosure. So they might be parentheses, brackets, they could even be absolute value signs. Any kind of enclosures are what we mean when we say parentheses. You're going to start with the innermost enclosure and then work your way out. So for this problem down here, the innermost enclosure would be right here. So that's the first one that we would do. So let's just work through this problem for the example. So 16 divided by 2 is 8. So we have 12 take away 8. And then we have 3. We have 5 on the outside. Alright, and next we will do, this is our next innermost. So 12 take away 8 is 4. So we have 2 plus 3 times 4 now. Alright, and the next one, we are working in here, and we have addition and multiplication. Which one comes first? Please eat more desserts. Nate's great strawberry mousse. So we are going to do our multiplication first. So 3 times 4 is 12. So we have 2 plus 12 times 5. And now we're almost done with this. 2 plus 12 is 14. So we have 5 times 14, which is 50 plus 20. So 70. Alright, so you're going to practice this. So you are going to try these 3 problems and make sure you work from the innermost enclosures out. And again, the order of operations steps we're following: please eat more desserts. Nate's great strawberry mousse. Alright, so pause it and try these, then hit play when you are ready to check your work. Alright, first one here, we're going to start with our innermost enclosure. 12 take away 2 is 10. So we have 10 divided by 5. And we have 18 plus that. Alright, next, 10 divided by 5 is 2. So we have 18 plus 2, which is 20. Alright, for B, innermost enclosure right here. So we have 6. So we have 8 plus 6. Alright, now 8 plus 6 is 14. So we have 14 divided by 14, which is 1. Alright, over here, it's a little hard to see this one. This is an absolute value. Our innermost enclosure is this one. So 4 times 3 is 12. So we have 12 take away 8. and that's in our absolute value. And all right, now 12 take away 8 is 4. So we have absolute value of 4. Absolute value of 4 is 4, so we have 26 take away 4. And 26 take away 4 is 22. Alright, here's an example, just getting a little bit larger here. Please eat more desserts. Nate's great strawberry mousse. So we're going to start with our parentheses, and we're going to start with the inside most ones. 12 divided by 2 is 6. And we have a 4 out here. Alright, now we still have enclosures that we're dealing with. 6 plus 4 is 10, so we have 18 take away 10. Okay, deal with that. 18 take away 10 is 8, and 4 times 8 is 32. Alright, so with enclosures, you're just going to start with the inside most ones and work your way out. Alright, so try these practice problems and then hit play when you are ready to check your work. Alright, so the inside most enclosure here, we have 10. Alright, now 2 plus 10 is 12, so we have 24 take away 12. 24 take away 12 is 12, and this is 36. Alright, next one, let's take a look at B. So for B down here, our innermost enclosure, we could start right here. 3 times 1 is 3. And we probably could have done this one over here too at the same time. But we'll just keep going with this one. 2 plus 3 is 5. So we have 4 times 5. Let's do this one over here. Plus 2, 8 take away 3 is 5. Alright. Now in this enclosure, 4 times 5 is 20. 5 times 2 is 10. Okay, now 20 plus 10 is 30. And 6 times 30 is 180. Alright, last one over here. 2 plus 3 is 5. And 2 take away 3. We have more negatives. How many more negatives? We have 1 more negative. Alright, 5 times negative 1 is negative 5. And then times 7, that's negative 35. Alright, so now just keep adding on. So now we have a longer problem here. Let's remind ourselves of our steps. Please eat more desserts. Nate's great strawberry mousse. Alright, so here we are looking for parentheses or any kind of enclosures. Right here we have one. 8 take away 4 is 4. So we have 2 times 4 minus positive 3. And it's best to just be very careful, and what I'm going to do here is every time after we do a step, I'm going to rewrite the rest of the problem, and we'll just keep working our way back that way. Alright, any more parentheses? Nope, unless you count these, which is just multiplication. Exponents. Let's do our exponent next. Well, we have 5 squared, which is 25. So we have 2 times 4 minus a positive 3 plus 25 minus 20 divided by 2. Alright, next any multiplication and division that we have. So we'll do this. This is 8. We have minus positive 3 plus 25. And now we have division here, 20 divided by 2. 20 divided by 2 is 10. Alright, next step. So we did our multiplication and division. So next step is neighbor sign. Do we have any neighbor signs? We do. So which one do we keep? When the signs are different, we keep the negative. And then we have plus 25, take away 10. Now we're going to group same signs together. Now we're going to do the same sign rule. 25 plus 8 is 33. 10 plus 3 is 13. 33 take away 13. We have more positives. The answer is going to be positive, and 33 take away 13 is 20. Alright, you can pause the lesson and try these. Let's remind ourselves of the steps. We have please eat more desserts. Nate's great strawberry mousse. So work through those and then hit play when you're ready to check your answers. Alright, first problem here for A. Any parentheses? No. Any exponents? Yes. 8 squared is 64. Okay. Any multiplication and division? Yep, right here we have division. 25 divided by 5 is 5. So we have 64, take away negative 10, plus 5. Now we have a neighbor sign rule to deal with. We have two negatives, so when the sign's the same, we're going to make it a positive. So we have 64 plus 10 plus 5. And now they're all the same sign, they're all positive, so we can just add them. So 64 plus 10 is 74, plus 5 is 79. Alright, for B, do we have any parentheses or enclosures? And we do. So we'll start with the innermost ones. We're going to start here. 5 plus 2 is 7. So we have 4 squared, take away 7. Now we still have to work inside our enclosures. We have brackets here. So following the order of operations in there, what do I do first? Subtract or exponent? We do the exponent first. Alright, now 16 take away 7 is 9, and 3 times 9 is 36. I'm sorry, 27. For C, let's see, no, oh, we do have parentheses. Alright, 10 take away 7 is 3. Alright, so we did our parentheses, we have no exponents. Multiplication, we have multiplication right here. Just get a different color. My pen keeps doing that. We have negative. Alright, so let's see, what do we have next? We did our multiplication, no division, so now we're going to do neighbor sign rule. And right here we have two negatives, so that's going to be a positive. And here we have different signs, so we're going to keep the negative. Now we're going to group positives together and negatives together. That's already done for us. Now we'll do the same sign rule. 8 plus 3 is 11. Negative 4 and negative 9 is negative 13. Now we'll do the mixed sign rule. We have more negatives. How many more negatives? 2. Alright, for D over here, start with our innermost parentheses or enclosures. 12 divided by 6 is 2. Okay. Alright, now inside our enclosure here, we have 2 plus 2 is 4. So we have 6, I'm going to write it a little below. We have 6 times 4. And we have -2 times -3. Alright, now we have multiplication. -2 times -3 is +6. And 6 times 4 is 24. And when you add those, you get 30. And last one here, let's see, we're going to look for parentheses or enclosures. We have some here and here. 10 take away 8 is 2, and 5 take away 2 is 3. Just put in the rest of the problem here. Alright, now in that enclosure we're going to do 2 times 3 is 6. Now, still working in the enclosure, 6 take away 4 is 2. Okay, now we're done with all of our enclosures, so no more parentheses. Now we do our exponent next. So we're going to do -9. We have 7 plus, I'll just write it as 2 times 2 for now still. Now we'll do our 2 times 2, which is 4. Alright, now we would group our positives and negatives together, which we already have. So 7 plus 4 is 11. Take away 9, which is 2. Alright, for multiplication and division, you're just going to do whatever comes first. So for this problem here, 20 times 4 is 80. Divided by 2 is 40. It doesn't really matter though, like which one you do first. If it's easier for you to do this, like 4 divided by 2 is 2. 20 times 2 is still 40. Here, 20 divided by 4 is 5, and 5 times 2 is 10. You know, it doesn't work for that one. Alright, so let's talk about this one again. For multiplication and division, we're going to do whichever comes first. So here, 20 times 4 is 80. 80 divided by 2 is 40. What if we did this one first for this one? 4 divided by 2 is 2, and 20 times 2 is still 40, so that would have been fine. But look what happens over here. 20 divided by 4 here is 5, and then 5 times 2 is 10. But if we did this first, 4 times 2 is 8. 20 divided by 8 is not 10, so that's not going to work out the same. So when we're following the order of operations, just make sure you do like multiplication or division, whichever comes first. That's the one that you're going to do first. Alright, try these problems and then hit play when you're ready to check your answers. Alright, so multiplication, division, do whatever comes first. 8 divided by 2 is 4, times 4 is 16. 2 times 4 is 8. 8 divided by 8 is 1. 6 times 5 is 30. Divided by 10 is 3. 10 divided by 5 is 2. Times 6 is 12. Alright, what about these problems? Let's look at how these are different. So here and here. Do you see how in this first problem that negative sign is not included with the 3 to be squared? But in this one it is. So for this one, it's like we have negative 3 times 3. So we are going to square the 3, and we're going to take the negative of that. That's going to be negative 9. But over here, see how the negative sign is included with the exponent? That's going to be negative 3 times negative 3, which is positive 9. Alright, same thing over here. The negative sign is not included to be squared, so this is going to be negative a times a. So it's going to come out to be negative a squared in the end. For this one, it is included to be squared, so it would be like negative a times negative a, and that's going to end up being a positive a in the end. So be careful with that. If you have a negative sign with your base, if it's included to be raised to the power, if it's included in the enclosure, then you can raise it to the power. If not, that just means you take the opposite sign of whatever you get when you square it. Alright, like terms. So this is the second part of the lesson. What are like terms? These things are all considered like terms, and why are they considered like terms? Because they are all numbers. So these ones are all like terms because they all have an a with them. These are considered like terms because they all have an a and a c with them. These ones don't have numbers with them also, but you would just say it's a 1ac or a 1ca. These would all be considered like terms because they all have an m, a c, and an a squared m, ma squared, and aam. These are all like terms because they all have two a's and an m that you're multiplying. Alright, let's look over here. These would not be like terms. They are not like terms because the 3 doesn't have a y with it, so you wouldn't be able to call these like terms. These are not like terms because this does not have an a with it, and this one has an a. These are not like terms because this has an a and this has a c. They don't have the same variables together. This has an a, c, and an m, and this has an a and a c. These are not like terms because they don't have the same variables. It would have to have an acm. A squared m, this means a, and m. Am squared, so that means a, m, and m. So you can see these are not the same. So in order for them to be like terms, they either have to be all numbers, or if they have variables, they have to have the exact same variables. The order can change. The order of the variables doesn't matter. ACM, MCA, as long as the variables are all there, then they would be a like term. So how to tell if something's a like term again? All numbers are like terms, even if they look different, like a fraction or a decimal or a negative. As long as it's a number, it would be a like term to another number. All terms with the same combinations of variables are like terms, whether or not the variables are in the same order. AXX, XXA. These would be like terms because they both have two x's and an a. These would be like terms because they both have a c and an a. A variable term standing alone and the same terms with a number in front are like terms. So these both have an a and a c. Those would be like terms. And we talked about before, you could easily say there's a 1 in front of that. So as long as they both have the same variables, then it would be like terms. Alright, so for these, what you're going to do is you're just going to say whether or not they're like terms. So you could just say like terms or not like terms. So pause the lesson, try these, and then hit play when you're ready to check your work. Alright, so for A, these are like terms because they're all numbers. For B, we have an xy, 7xy, and 300yx. Even though the order switched, it is still in an x and a y. So these are like terms. 12 MRP, 6 PR, and 9 MR. These don't all have the same variables. This one's missing an M, this one's missing a P, so these are not like terms. P squared, Q squared. P squared here and a Q squared here. They're just different order. But look at here. These don't have the squares, so they don't have the same variables, because this would be a P, a P, a Q, and a Q. A Q, a Q, and a P, and a P. This is just one Q and one P. So these are not like terms. FGH, GHF, HEF. These are like terms, they're just in different order. Alright, so when things are like terms, that means you can combine them. That means that you can add or subtract them. Let's do two of these together. So for this one, these are like terms because they both have the same variables here. 9b plus 1b is 10b's, so we'd say 10b. 13xyz, take away 1xyz, it's going to be 12xyz. So it's important to know what like terms are, because then you know when you can perform operations with them like this. Alright, why don't you pause the lesson and just try C through E here, and then hit play when you're ready to check your work. Alright, so for C, PQ plus PQ equals 2PQ. This would be 4Ys, and this is going to be 0. Alright, let's look at some examples here. Same sign rule. So now we're just going to go through the rules like with things that have variables, so we can see how you do it with like terms. Negative 3a and negative 5a, well, they're like terms. They're both negative, so we're going to keep the negative. And negative 3a's and negative 5a's means you have negative 8a's. Positive 3a's and positive 5a's means you have positive 8a's. Here we have PQ and a PQ, so we have 3 positive PQs and 8 negative PQs. We have more negatives. How many more negatives? We have 5 more negatives. So we're going to be left with negative 5 PQs when we combine those. Here we're going to have more positives. And how many more positives? Well, the difference between 8 and 3 is 5. Alright, neighbor sign rule. We're going to, when the signs are the same, we'll keep it positive. So 9v plus 5v is 14v. Signs are different, so we're going to use a negative. 9v take away 5v is 4v. Signs are the same, so we're going to make it positive. So we have 14v. Signs are different. Oops, there's supposed to be a v here. So we're going to make it minus 4v. Excuse me. Alright, so go ahead, pause it and try these, and then hit play when you're ready to check your work. Alright, so here, same sign rule. We have negative 7ab. Here we're going to do the neighbor sign rule first. So we have 8 plus 2x squared. But you know what? This is as far as we can go. We can't combine those anymore. And we haven't talked about this yet, but when you are writing a solution, you want to start with the highest power first. So the right way to write this would be 2x squared plus 8. Here we have an xyz and an xyz, so we can combine these. This is called combining like terms. So we're simplifying these or combining like terms. We have negative 7 and positive 10, so we have more positives. How many more positives? We have 3, so it's 3xyz. Here we have a squared b, a squared v. So these are like terms, we can combine them. Two signs right next to each other. So we're going to do the neighbor sign rule, so that means we're going to keep the negative when they're different. Alright, and now we have more positives, the answer is going to be positive, and 13 take away 4 is 9. Alright, like terms here. We have a positive PV and a negative 10 PV. So we have more negatives. How many more negatives? 9. RS and RS, these are like terms. They're both positive. So our answer will be positive. So we're going to have 17 RS. All right, just getting more complicated here. You can see here that these are like terms and these are like terms. So we can combine the like terms. First, let's get rid of the neighbor sign, the double signs. We'll use the neighbor sign rule. So we have 6v take away 2xy plus 8v plus 4xy. Alright, now these are like terms and these are like terms, so let's write them together. 6v plus 8v, negative 2xy and positive 4xy. Alright, so now 8v and 6v is 14v, and 4xy and negative 2xy, so it's going to be like we have 4 positives and 2 negatives, so we have more positives, we have 2 more positives. And that's as far as you can go. You can't combine these because these are not like terms. Alright, so try these problems and then hit play when you are ready to check your answers. Alright, first thing we're going to do here is let's get rid of the double signs. So we have 8a plus 9c, take away 2a, take away 5c. Alright, now we're going to group these. We're going to do our grouping. So let's do like terms together. So we have 8a, take away 2a, and then 9c, take away 5c. So we have 6 a's, and 9 take away 5 is 4. Right, next one. Get rid of that double sign, so we have 2 plus 3x plus 7 take away 4x. Now let's group them together. Let's do 2 plus 7 and then 3x and 4x. 2 plus 7 is 9, and here we have more negatives for the x's, so we have 9 take away and we have 1 more x, so 9 take away an x. For C, let's see here. First, let's get rid of our double signs. So we have negative 5 RS, take away Z, take away 8Z, take away 6 RS plus 4Z. Alright, like terms, we have this one and this one. And then we have our Z's. So we have negative 5 RS, take away 6 RS, minus Z, minus 8Z, plus 4Z. Alright, so we have 11, negative 11 RS, 8Z, take away Z is negative 9Z, and then we have 4Z. So what I just did there is I did the same sign rule, and now we're going to do the mixed sign rule for the Z's. So we're going to have negative 11 RS, and for the Z's we have more negatives, and how many more? Well, 9 take away 4 is 5. Alright, for D, let's see, double sign, so let's rewrite that. Negative 1 take away x, take away 1, plus x, plus 1. Alright, let's group our like terms together. Negative 1, negative 1, positive 1, negative x, positive x. Alright, now let's add the same signs together. So we have negative 2 plus 1, and over here we have negative x plus x. negative 2 plus 1, we have more negatives. So we have negative 1. And then negative x and positive x, those will cancel out. So our answer for that one's just negative 1. All right, here, double sign, double sign, double sign, bunch of them. So we have y, take away z plus y. All right, let's group our like terms together. And then we add, within our like terms, we add the same sign. So we have 2y and negative 2z. And that's it. All right, let's take a look at what this means. If you have a plus a7, or if you have a plus sign outside the parentheses or a negative sign outside the parentheses, you could think of this like a distributing like a positive one or a negative one. And let's look at that. If you just distribute a positive one there, you're going to get a take away 7. It doesn't change anything. But what happens when you distribute out a negative one? You're going to get negative 1 times a, which is negative a, and negative 1 times negative 7, which is positive 7. So if you have a negative sign outside of the parentheses like this, it's going to change the sign of the numbers inside the parentheses. So if there's no number with it, just put a 1 in there and you can distribute it out. All right, so why don't you go ahead and do these ones for the practice and then hit play when you're ready to check your work. All right, we'll put the 1 there, distribute that. It's going to just stay the same. So we have x take away 9. We'll put the 1 here and we're going to distribute that. Negative 1 times x is negative x. Negative 1 times negative 9 is positive 9. So you can see what happened. It changed the sign. When the negative sign was on the outside, it made everything that was on the inside different. All right, we'll distribute out that positive sign, or that positive 1, and it doesn't change anything. All right, what if it was a negative 1? Negative 1 times x would be negative x. Negative 1 times y would be negative y. And negative 1 times negative z would be positive z. All right, put a 1 here. 1 times 17 is 17. 1 times negative m is negative m. All right, for this one, 9 plus a minus 7. So you can just see now we're adding on to it again. So we can get rid of the parentheses by just distributing that out. So we have 9 plus a, and then positive 1 times negative 7 is take away 7. Okay, now we can combine like terms. So 9, and we'll just write them together first. Now 9 take away 7 is 2, so we have 2 plus a. Over here, let's put the 1 in there. We're going to distribute that out. So we have 9 take away, well, negative 1 times a is negative a, and negative 1 times negative 7 is positive 7. Now we'll rewrite it with our like terms together. 9 plus 7 is 16, so we have 16 take away a. Alright, so you're going to practice these ones. You can just put a 1 right in here. You're going to distribute out that 1 and then rewrite the problem. Alright, so go ahead and work through these and hit play when you're ready to check your answers. Alright, so distributing that out, we have 11 plus 1 times c is c, and 1 times 4 is 4. Let's rewrite that, putting our like terms near each other. Now we'll add our like terms. 11 plus 4 is 15. That's as far as you can go with that one. Alright, for the next one, let's put a 1 in here. So we have 11, and then negative 1 times c is negative c. So it's going to be negative c. And now negative 1 times 4 is negative 4. Let's rewrite this, putting our like terms together. Okay, 11 take away 4 is 7, so we have 7 take away c. Alright, here we'll write our number 1 in. We have 13. Negative 1 times d is negative d, and negative 1 times negative 9 is positive 9. Now let's rewrite that, putting our like terms together. 13 plus 9 is 22. So we have 22, take away d. Next problem, we'll put a 1 in here. So we have 13, take away d, take away 9. So we have, let's rewrite it, putting the like terms together. 13 take away 9 is 4, so we have 4 take away d. And the last problem, put a 1 in here. So we have 14, take away x, and then negative 1 times 2 is negative 2. Rewrite that, put the like terms together. 14 take away 2 is 12, so we have 12 take away x. Alright, so let's see what happens here. So, is this what happens? Let's look. We had 2a times 3a. You can say, alright, well, these are like terms. 2 times 3 is 6, so this is going to be 6a. No, no, no. What you're doing here is you're multiplying 2a's times 3a's. That is actually going to be 6a squared, because we have to remember that we multiply both those a's together. Okay? 8a divided by 4a, you can't, it's not the same way as it is with addition and subtraction. You can't just say 8a take away 4a is going to be 2a. That only works when you're adding and subtracting. When you are doing division, 8a divided by 4a, 8 divided by 4 is 2, and a divided by a is 1, so it's just going to end up being 2. So just be careful with that. Like terms apply when you're doing addition and subtraction.